For practice problem number 2, as always, we want to focus first on what is the question asking us to figure out. They say determine the distance for line segment AB, that red or maroon line here, and then you're going to estimate your answer. This is important to the nearest tenth. Always pay attention to directions like estimate your answer to the nearest tenth. I'm going to go ahead and highlight that so we remember to pay attention to that. So the tricky thing for this problem we see now, we don't have a rectangle anymore. We just have a diagonal line, and they say how long is that? But we know if we could form a right triangle from earlier problems, the right triangle would help us determine the length of the diagonal distance. I need the right triangle to have horizontal, a straight sideways, and a vertical leg. So on the whiteboard, I'm going to show you here we have A and B, and I would be connecting those, making a right triangle by drawing one leg straight sideways, one leg straight down. And that way when they come together, they're going to form a right angle and give us a right triangle we can work with. Now we're going to see the distance across sideways. The x value at point A is 2. The x value at point B is 5. So if we go from 2 to 5, we know this must be 3 units across. And the y value goes from 2 to positive 9. So it must be 7 units up. Double check on our graph here. We could count across 1, 2, 3, and then up 1, 2, 3, 4, 5, 6, 7. But again, we see the coordinates make it a bit easier to understand. At this point, once we know the value for the 2 legs, we know that's going to be our A and our B. What we're trying to find is really the hypotenuse. This diagonal line is going to be C. So I plug in a 3 for A. I plug in a 7 for B. And this should be pretty familiar for you all, so I'll go through it pretty quickly now. You should recognize we need to be squaring or applying the exponents first, and then combining like terms. So we simplify 3 squared plus 7 squared. We evaluate that. We get 58. What's the inverse operation for c squared? To get rid of the squared, we do the square root. That gives us c. We have to apply the same operations to both sides of our equation as we transform or change it. The square root of 58, we know it's going to be somewhere around 7, because the square root of 49 would be 7. The square root of 64 would be 8. We're going to need a calculator at this point. Remember, we highlighted round the nearest tenth. So if we do the square root of 58, we see we get 7.6157. I'll write down a few of those digits. We know we're rounding to the nearest tenth. We look at the 6. The next digit is a 1, so we're not going to round up. We just leave this. The distance from A to B is going to be approximately 7.6 units.